All right, this is part 4 of 4, constant acceleration quiz practice. And so I'm going to go over the graphing and the motion map here. All right, so we've already found the information for the velocity time graph. And so what we're going to do next is probably label all the grid lines so that it makes sense for us when we start graphing. So I'll go by ones for the time because our delta t here was about 1. And I think for the velocity, I will do maybe a delta V of 5. So I'm going to space it out and count by 5s for each line. And so that's so that when I get to time 8, that 42 gets in there. And I should really have done it for 9 and 10 as well, but I totally spaced on it, right? So here, we'll start with 4 because that was the first one that we found. And at 4, it was 22 meters per second. And at time 6, it was 32 meters per second. And then time 8 was 42 meters per second. And then I'm going to go ahead and fill in at 0. Our initial velocity was 2 meters per second. And you could probably just go ahead and fill in for all of them, or you could just stop here like I did and draw your slope. So the slope here with the initial velocity at 2 meters per second and then all the points that we found earlier should give us an acceleration of the 5 meters per second. So I will go ahead and label the points here in pink, right? So we've got 4 with 22, 6, 32, and whoops, let me rewrite 8 with 8 being at 42 meters per second. Right? And so if I used any of these points, I would surely, hopefully get 5 meters per second as my slope. All right, so here, this is our position time graph, and we're just going to go ahead and find out what the acceleration is based on that information. And we'll also use the position to find out how much space we need to label each of these intervals by, right? So since we went up to like 200, we should definitely make sure that our numbers go to 200. I think it was like 287, right? So if I go by 50s, let me just try it out here. It'll take me all the way to, looks like we're going to go like quite far. We're going to go to 450 and then 500, but I don't need to go that far, right? Like I just need to get to 278, I believe. So I don't need 300 to 450. Maybe if I just spread it out more, like maybe if I can go by 25 meters, then I might have a better picture of what we're doing. So I'll go by 25s. And again, like you could probably just do what you want to do, but I want to make sure that the picture is really clear and really visible and easy for whoever's going to look at my motion map, see that that's what I'm doing. All right, so this goes to 250 meters, but I want to make sure that it goes to 278. So I'll probably just stop here at 275 because I've definitely run out of room. All right, so let's remember what our data was, and our time 0, I believe, was at 8 meters. So I'll just draw this time 0 dot right here. And at 2 seconds, it was at 22. At 4 seconds, it was at 56. At 6 seconds, it was at 110. At 8 seconds, I know, I'm sorry. I just really want to make sure that this picture looks good for you guys. So at 8 seconds, it was 184. And at 10 seconds, that's where it's at 278. And now we'll go ahead and draw our velocity vectors. Remember how we've changed from calling them velocity arrows, and we're calling them to what they really are, velocity vectors. Okay, so we see that the arrows are getting longer as we draw them. And we're going to draw our acceleration vectors. And remember, those vectors represent 5 meters per second every second. And so we're going to draw it proportionally to how big our motion map is. Okay, so I'm going to go ahead and guess it's about 5 meters per second. It doesn't have to be super exact because you're probably not going to be able to measure it like this, but you should at least have it like proportional, right? So this whole thing goes up to 275 meters. So you shouldn't be drawing super long arrows to show that it's